All right, today we are going on a fascinating tour of your body's most vital delivery system. I'm talking about the powerful engine that runs 24/7, never takes a day off, your cardiovascular system. So let's dive right in.
Have you ever wondered what network inside of you is always on the move, making deliveries to and pickups from every single one of your trillions of cells? Well, the answer is, of course, the star of our tour today.
So, at its core, the idea is actually pretty simple. It's a closed loop, which just means your blood never actually leaves this network of tubes. And its mission is basically twofold. Drop off all the good stuff, like oxygen and nutrients, and then haul away all the waste, like carbon dioxide. It's really the body's ultimate logistics company.
Okay, so here's our itinerary for the tour. We're going to start with the system's mission and meet the key players. Then we'll zoom in on that powerhouse pump, the heart. We'll take a peek inside its chambers, explore the incredible highway system of vessels, and finally, we'll trace the two main routes that your blood travels every single day. First up, let's meet the team that's responsible for this whole critical operation. The entire system is really built from four core parts. You've got the heart, which is the central pump, of course, and then you have three types of blood vessels: arteries, veins, and the tiny little capillaries that connect them all. Each one has a very specific job, and we're about to see how they all work together in perfect harmony.
Now, let's focus on the undisputed MVP of the entire system, the heart. And it's not just a pump, it's the powerful, relentless engine that drives absolutely everything.
So just how big is this engine? Well, go ahead, make a fist. That's roughly the size of your heart. It's this amazing four-chambered muscular organ, and it's tucked safely away in your chest, in a space between the lungs called the mediastinum, right behind your breastbone. It is incredibly well protected, and for very, very good reason.
What's really cool is how the heart is built. It's constructed in layers, kind of like an onion. On the very outside, you have the pericardium. That's a loose, protective sac. Then you got the epicardium, which is the outer wall itself. Then comes the real workhorse, the myocardium. This is the thick, powerful muscle that does all the squeezing. And finally, on the very inside, you have the endocardium, which is this super smooth lining that makes your blood flows without any snags.
Okay, let's step inside. You see, the heart isn't just one big pump. It's actually this cleverly designed little house with four distinct rooms and some very important one-way doors.
The top two rooms are called the atria. You can think of these as the heart's receiving docks. This is where blood, coming back from the body, first arrives. Then, below them, you've got the two powerful ventricles. These are the shipping departments, the really muscular chambers that forcefully pump blood out of the heart and onto its next stop.
So how does the system keep all this blood from going the wrong way? Well, that's where the valves come in. These things are basically perfect one-way doors. They swing open to let blood pass through, and then they snap shut to stop it from flowing backward. It's such a simple but absolutely flawless piece of engineering. So the heart provides the push, but where does the blood go? Well, it enters this huge interconnected network of vessels that's basically a biological highway system. And when I say it's vast, I mean it. If you could lay out all the blood vessels in your body end to end, they would stretch for nearly 100,000 kilometers. That's enough to circle the Earth almost 3 times.
Now, the two main types of highways are arteries and veins. And here's a really simple trick to remember the difference. Arteries carry blood away from the heart. See? A for arteries, A for away. They're the distributors, taking all that fresh, oxygen-rich blood out to the body. Veins, on the other hand, bring the used unoxygenated blood back towards the heart. They kind of act as reservoirs, holding that returning blood.
But these huge highways can't deliver a package directly to every single house, or in this case, every single cell. For that, you gotta get off the interstate and onto the local streets.
And that is the job of the capillaries. These are the microscopic vessels where the real action happens. They're the bridge between the arteries and the veins, and it's in here that the blood flow slows way, way down. And that's on purpose. It allows enough time for that crucial exchange of oxygen and nutrients for waste products, right at the cellular level.
Okay, so now that we've met all the components, let's zoom out and really see how it all fits together. The entire system is organized into two major loops, or circuits, that both start and end right at the heart. First up, you have the pulmonary circuit. Think of this as the short loop, the quick trip. The right ventricle pumps used blood on a short journey to the lungs, and its only goal? To get rid of carbon dioxide and pick up a fresh supply of oxygen. As soon as it's reloaded, it heads straight back to the heart's left atrium. Job done.
And then you have the systemic circuit. This isn't the short loop, this is the grand tour. The super powerful left ventricle pumps all that fresh, oxygenated blood out to literally every other part of your body, from the tip of your brain to the tips of your toes. After it delivers its payload, the now deoxygenated blood makes that long journey all the way back to the heart's right atrium, and the whole amazing process starts all over again.
Now, here's a really fascinating little detail. With all of that blood pumping through the heart's chambers, you'd think the heart muscle would just grab the oxygen it needs right from there, right? But it doesn't. The heart is so important that it actually has its own dedicated personal circulatory system, the coronary arteries, just to feed its own muscle tissue.
And that leads to one final kind of mind-bending thought. We've seen this incredible mechanical pump, with its own fuel lines running a delivery network of unbelievable complexity. It powers itself, it nourishes itself, but what provides the spark? What's the invisible electrical signal that tells this muscle to contract over 100,000 times a day for your entire life? Well, that's a story for another time.